We now give the official determinant formula. But first, permutations and signs. Without assuming group theory, civilization barely survives notation as it is. A permutation of 1 through n is just a rearrangement of those numbers. Every number appears exactly once. No group theory required. Everyone may unclench. We write a permutation as sigma. Sigma of j tells us which row we choose from column j. To get the sign of a permutation, count inversions. An inversion is a pair of entries that is backwards compared with normal increasing order. Here, 3 is before 1 and 2, so we get 2 inversions. 2 is even, so the sign is +1. The most important fact is simple. Swapping 2 entries flips the sign. This is how determinant keeps track of orientation, instead of politely pretending order does not matter. For 2 by 2 matrices, there are only 2 permutations: keep the order or swap the order. The identity permutation has sign +1. The swap has sign -1. This tiny fact will produce AD minus BC. Now the definition. For each permutation sigma, choose one entry from each column. Row sigma of 1 in column 1. Row sigma of 2 in column 2. And so on. Then multiply those entries. Multiply by the sign of sigma. And add over all permutations. This is compact notation, which is math's favorite way to hide paperwork. For a 2 by 2 matrix, the formula has only 2 terms because there are only 2 permutations. The identity permutation chooses row 1 from column 1 and row 2 from column 2. That gives A times D. The swapped permutation chooses row 2 from column 1 and row 1 from column 2. The sign is negative, so we subtract C times B. So the 2 by 2 determinant is AD minus BC. Same formula as before, now produced by the formal definition instead of geometric intuition waving its hands around. For 3 by 3, the formula already has 6 terms. For 4 by 4, 24 terms. The factorial growth is not a feature. It is a hostage situation. So this formula is great for defining determinant and proving theorems. It is not how sensible people compute large determinants. We will use row reduction later, like adults with survival instincts. Next time, we prove why this ugly-looking sum is actually the unique normalized alternating multilinear function. In other words, the formula is not random. It only looks random because notation enjoys dressing like a bureaucratic nightmare.